one what? It's not just like a quick answer, this kind of a question here, question number C. Because with C, the idea is, right, you see here they ask for the coordinates of K. K is the turning point, which we somewhat don't need for C. But then to get the turning point, it says in the in the adjacent graph, the equation of the parabola is this one. So we have the equation of the parabola, perfect. And then we have the equation of the straight line or straight lines. There's this straight line here. This is the straight line here. The one down here is y is equal to -4. So by default, this y value is a -4. And then the other one is this one with the negative gradient. Fine. This is a -2, so this is a -2. Fine. That's not very important for question C. Even getting the length of AB, we don't need it. Question C is saying we need we should determine the maximum possible length of PT. So this kind of a question is very special. This could easily be like a 7-mark question, like honestly, because remember we're looking at it from a grade 11 perspective. If this was a grade 12, if we were, let's say, in grade 12 right now, we would be doing something different, but not so much. Here, what you need to recognize is from P to Q, from P to T, fortunately, this is a 90-degree angle. What that means is this is a straight line going down, meaning the X value up here is the same as the X value down here. So for you to get the distance of PT, you only need to make use of the Y values of these two graphs. The Y value here minus the Y value up and down there is going to give you the distance of PT. So what we know is at point P, the Y value of P here, you will always get it from the equation of the straight line. The Y value of T, you'll always get it from the equation of the parabola. So the distance PT by default is always the Y value of the straight line, which is this equation here, minus the Y value of the parabola, which we can get from this equation. So this is where you start. You see the distance is always whatever is on top here minus whatever is down there in terms of their equations. So with this equation, what you then want to do that is actually quite interesting is you want to obviously simplify, right? And when we are going to simplify here, 99.99% of the time, we're going to get a parabola. Well, in grade 11, you're technically always going to get a parabola. If you're technically always going to get a quadratic equation when you simplify. So simplifying here, you have this. If you multiply inside here, you're going to have a negative this, negative that, positive that. Some more, you have negative 2x squared. This minus that is negative 4x. This minus that, you're going to get positive 3. So the funny enough, what you want to recognize is that this is just an equation. And if you look at this equation, this is clearly a parabola that would have a frowning face. You see, so because of this negative here, automatically. So the fortunate thing is the way these questions are designed, right? You see here, they're asking you to determine the maximum possible length of PT. So what you know is this equation here, right, gives you the length of PT. So this equation gives the length of PT depending on the X value. So what that means is, you see where PT is. What they're trying to tell us is that PT is going to be any line between our straight line and our parabola. Because if you look at where the parabola is, right, the parabola is this portion here is the portion where we have our parabola. And then the portion up here, let me use the blue here, the portion here, right, is our straight line. So if you look at PT, oh, come on, man, PT. If you look at PT, PT is not always just this line here. PT could be this line here, but you can see that's a bit shorter than what we currently have. PT could be this line here. You can see that might be a bit longer than what we currently have. PT could be this distance. Do you see that depending on what you consider, or depending on which x value you look at, the length of PT would change. Do you see that?
Yes.
Because P would just be the point up there, T the one down there. So the idea is they want us to figure out which x value, so which x value, right, would result in us having the highest possible length for PT. That's what they want us to work out. So getting that x value that will have the maximum length, you want to remember this is just an equation, right, that will give us the length of PT. So if you look at it logically, the x value here, right, that will give us the biggest outcome is going to be the x value of the turning point. Of turning point. Because when we're looking at this equation, even though this equation is an equation of a parabola, it's still a distance equation for our line PT. So because it's a distance formula for our line PT, we know that the x value that will give us the biggest distance is the x value of the turning point of this. So that's why with the equation of PT, we just have to work out the x value of the turning point. You see, so working out the x value of the turning point here, we're going to have negative, and then our b values are -4, our a values are -2. This up here is going to be a +4, right? And then this times this is a -4, this is going to be a -1. So this is telling us that the x value that will give us the highest distance is just a -1. So since here they want the maximum length, right? We know that we will get it as long as we put x as -1. So in our equation for PT, where x is, we're going to throw -1 there. So here we're going to throw -1. We're going to have 2, -1 there squared, -1 there, and then +3 over there. That's the way we like it. This is going to be 1. This is going to be -2, +4, +3. This is a 7 minus 2. That's a 5. Do you see it?
Yes.
Perfect, perfect, perfect. So that's how you would answer this kind of a question. The maximum distance for PT is a +5. It's 5 units. That's the highest possible distance. And voila.
I understand how you did it. But then
Mhm.
my teacher, right, when he was
Completed the
looking
square.
at this question, he used this other formula that was like minus b minus 4ac over 4a.
Minus b minus 4ac over what?
4a.
4a. Wait. So wait, in other words, so remember, if you look at it, if you think of it logically, right, this is the x value that would result in the highest distance. But then if you look at it in another light, if you're looking at this as a parabola, technically, if you're going to throw a -1 here, which is the x value of the turning point, what you would be technically getting here is a y value of the turning point, if you're looking at it in the perspective of a parabola instead of a distance formula. So if you think of it nicely, right, if the x value of the turning point is minus b over 2a, or that, I'm going to call this person later, or that is different is that if you think of the equation of a parabola, right, like y is equal to ax squared plus bx plus c. Technically speaking, if you throw in this as the x value, what are you going to have? The a minus b over 2a squared plus b minus b over 2a plus c. If you simplify this, this is squared, right? So everything has to come out as a plus. So you're going to have b squared here over 4a squared. Here, these two multiplied together will be negative b squared over 2a and then plus c. If you simplify some more, you would have ab over 4a squared minus b squared here over 2a plus c, which is just like, okay, it makes sense, but it's so unnecessary. But I don't know if this is what you're referring to, or it looked a bit different.
Yeah, it's something like that. Yeah.
Yeah, so you see, this is super unnecessary. But then if we can test it, right? If we put in these values a, b, and c into this equation here, we should come up with the 5, if unless we have made a mistake. But let me just double check quickly so that we can see everything is fine. Yeah, everything looks fine. Squared, blah blah blah. Yeah, if we take this equation here, let's do this. Let me just remove this here so that it's not copied. If we take this equation here, do that, copy, do this, paste. If we're looking at it nicely, right? Let's say here y is equal to, the a value is like a -2. The b value is like a -4. And then here a value is a -2. You can actually put this in the calculator. And then b here is a -4. A is a -2. C is a 3. Moment of the truth. Fraction, -2, -4 squared, 4, -2 squared, minus fraction, -4 squared, 2, -2 plus 3, 5. See, still coming out as a 5. But then doing it like this is so unnecessary, because it's like, why the risk of all this? We can just easily get the actual x value, check, and then throw it into the equation.
Oh, okay.
Nice. We is love to see it.